Let's practice finding some more roots of real numbers. Here I have the fourth root of t to the eighth. The fourth root of t, I have 8 t's, right? And I want 4 sets, so I've got 1, 2, 3, 4 sets of t squared. So if I have the fourth root of 4t squared, that would be the fourth root of t to the fourth, and anything, the fourth root of anything to the fourth power is going to be equal to whatever's inside the radical sign, and so that is et squared. Now you don't have to go through all of this writing this out. You can, with your knowledge of exponents, you could have said what t raised to what equals raised to the power 4, and then you know to multiply these two together to get your 8. You can do that in your head, or you could just look at this and know how to break it up. That's fine. But if you don't, the easiest way is just to break it up and then count your pieces. Here I have the cube root of negative 125. Now, you may know what the cube root of 125 is, but I'm going to factor tree this, assuming that I don't know. And I end up with 2, 5, 5, and 5. So the cube root of negative 5 cubed is equal to negative 125. So the cube root of anything raised to the third power is going to be that number. And here I have the fifth root of 32 into the fifth power. Now I know I can take the n out of this root. If I look at 32, let's assume I don't know the factors of 32, so I just factor tree it. And I end up with 5, 2, so I have the fifth root of 2 to the fifth, n to the fifth. I can take out a 2 and I can take out an n. And that's the fifth root of 32 n to the fifth. Here I have 16a squared b to the fourth. My index is not written, so I know that it's 2. So I want to break this down into 4 squared a squared and then b squared, because b to the fourth equals b squared times b squared, correct? So I can take out all of my squares, and I get 4a, and then I have a pair of b squares, right? So I have b squared squared that I'm going to take out, so I'm going to take out a b squared. And here I have the square root of the quantity y plus 1 squared. Anything, I take the square root of anything squared is just that number, so this equals y plus 1. So I don't need to FOIL this. I don't need to do anything. If I just take out whatever squared. If there were additional terms onto this, I would need to do something else. But since this is the only thing under the radical sign, the only term under the radical sign, and it's squared, then the square root of that is just what is squared. So y plus 1. Here I want to factor this trinomial, and if I factor this, I get x plus 3, x plus 3, and that equals the square root of x plus 3 squared. So again, the square root of anything squared is going to equal whatever squared, so the answer to this is x plus 3.